Introduction and Chemistry 20 Review for completing the reaction, assignment BR10 and 11. The purpose of completing the reaction is to identify the type of reaction that would occur and what the products will be when given the reactants. The notes are already given to you, so you do not need to copy them down, but you need to take down the examples at the end of this lesson. Decomposition reactions. These are easily identified because there is only one reactant. There are three types of decomposition reactions we have to be familiar with. The first is when you are given an ionic compound. Complete the decomposition reaction by separating the cation from the anion. This is very common when ionic compounds are placed in water. The salt will separate into its positive and negative charges. When given a covalent molecule, complete the decomposition reaction by separating the covalent molecule into the elements of which it's composed. Diatomics will take their diatomic form, and non-diatomic nonmetals will become lone elements. If starting with a hydrated compound, it will be expected that a heating of the compound will cause the water to separate from the ionic compound. Synthesis reactions. Two reactants become one product following one of two forms. When given a cation and an anion, they will combine to be a neutrally charged ionic compound. Ca2 plus and OH minus will come together. Lowest common charge is 2, so I need 1 calcium and 2 hydroxides. I then balance the equation. The other possibility is the combination of a metal with a nonmetal, yielding an ionic compound after an exchange of electrons. Make a note that metals take positive charges and nonmetals take negative charges. Aluminum is a metal, so we know it takes a positive charge. When I look it up on the periodic table, inside its box I see a 3. So aluminum takes a +3 charge. After the exchange of electrons, aluminum has given up 3 electrons to become Al3+. Cl, when I look it up on the periodic table, it is a nonmetal, so therefore it takes a negative charge. So I go to the negative ions list and I look up Cl, and I see that Cl takes a -1 charge. After the exchange of electrons, each chlorine will pick up a single electron, becoming chloride. With a +3 and a -1, lowest common charge is 3, so I need 1 aluminum and 3 chlorines. I then balance the equation. Before we go on, a note about the synthesis reactions in your assignments. In the questions you will be given, the metal will only have one charge option and the anion will be easily recognizable. Otherwise, the combination could yield a number of different products, making it difficult to determine the outcome. Synthesis reactions in this course will not include the mixing of two nonmetals, since they can produce a number of combinations when they react, and determining the exact product is also difficult. Single displacement reactions. These reactions will have a single species reacting with an ionic compound. The single species replaces either the cation or the anion in the ionic compound. Let's say we have magnesium reacting with hydrochloric acid. If we look at magnesium on the periodic table, we see that it takes a +2 charge. And hydrochloric acid, from experience, we know is composed of H+ and Cl-. Well, if magnesium with a +2 charge is going to react with someone, it's going to be something with a negative charge. So the magnesium with a +2 charge is going to go with the chloride ion, forming MgCl2, which means the H will be displaced. Now, the note says when the single species going into the reaction is not charged, the replaced ion cannot leave with a charge. Since magnesium did not come in with a charge, that means hydrogen cannot leave with a charge. But hydrogen can't leave just as H. It is a diatomic, so I have to put a 2 on the hydrogen. Then I will balance the equation, and I'm good to move on. Now let's say that magnesium was coming in with a charge. Well, we got Mg2 plus, and again H plus and Cl minus. Magnesium with its positive charge will still go with the chloride, making MgCl2, but this time hydrogen is leaving with a charge. The note says when the single species, in this case magnesium with a +2 charge, so when the single species going into the reaction has a charge, the replaced ion must also leave with a charge. When we balance the equation, we will see that not only do the elements balance, but so does the charge. On the left-hand side, we have a +2 with the magnesium. On the right-hand side, we have 2 + 1 charges due to the hydrogen ion. So we have a +2 charge on either side of the balanced equation. A note on single displacement reactions, and I point this out because this is one of the most common mistakes students make. Chlorine is a nonmetal. Nonmetals take negative charges. So in this situation, chlorine will replace the anion in the ionic formula. Chlorine, if we look it up on the negative ions list, is Cl minus. Ki is comprised of K plus and I minus. So we know the Cl minus is going to go with K plus, making KCl, and the I will have to leave all by itself without a charge because chlorine came in without a charge. But it can't leave as just I because it is a diatomic, so it will need a 2. Now we balance out the equation, and we're good to move on. Double displacement reactions. These are typically reactions with two ionic compounds. Cations exchange anions, and the new formulas are written so the result has a neutral charge. K2S is composed of K plus and S2 minus. AlCl3 is composed of Al3 plus and Cl minus. In a double displacement reaction, they will switch their partners. So K plus will go with Cl minus, making KCl. Al3 plus will go with S2 minus, forming Al2S3. And then we balance the equation. Combustion reactions. These are recognized by the combination of an organic with oxygen. The resulting products are always carbon dioxide and water. They then need to balance. Example 1, copper 2 sulfate pentahydrate. Copper 2 is copper with a +2 charge. Sulfate is SO4 2 minus. We bring that together, that makes CuSO4. We have penta, which means 5, and hydrate, which means water. So this is a hydrated salt. So I have to add 0.5H2O to the formula. And I recognize that this is a decomposition of a hydrated compound, which means I will just rewrite the formula, except the CuSO4 and the 5H2O will be separated from one another. So CuSO4 plus 5H2O. Example 2, we have copper 1 ion, which is copper with a +1 charge, and that's reacting with hydrosulfuric acid. It says acid, so we know we have H plus on the front, and since we have hydro and ic in the name, the original ending was ide, so we're looking up sulfide on the negative list, which is S2 minus. Bring that together, copper 1 ion is reacting with H2S. Now we see that we've got something by itself in copper 1 ion and a pairing with H plus and S2 minus together in hydrosulfuric acid. So that means we have a single displacement reaction. Now the copper 1 is coming in to react with somebody, and since it has a positive charge, it will react with S2 minus. And when they come together, that will make Cu2S. That means that the hydrogen has been displaced. And since copper came in with a charge, that means hydrogen must leave with a charge. Then we'll balance the equation, and the question is complete. Example 3, we have CH4O, which is an organic, reacting with oxygen, which means this has to be combustion, and the products are always carbon dioxide and water. Then we balance, and the question is complete. Example 4, SO3. It is not reacting with anything, so it has to be decomposition. It's a covalent molecule, and we said when there's decomposition of a covalent molecule, we break the elements up into their simplest form. The simplest form of sulfur is just S, and the simplest form of oxygen is O2 because it's a diatomic. Then we balance, and the question is complete. Example 5, potassium plus sulfur. Potassium is just K, and it's reacting with sulfur, which is just S. We have something by itself reacting with something by itself. This has to be synthesis. Now, if it's coming together, odds are one takes a positive charge, the other takes a negative charge. Potassium is a metal. Number 19, it takes a +1 charge. I look it up on the periodic table. Sulfur is a nonmetal, so therefore I look for it in the common negative ions data table, and I find S2-. And when K plus goes with S2-, lowest common charge is 2, I need 2 Ks and 1 S. Now I balance the equation, and example 5 is complete. Example 6, we have potassium hydroxide, so that's K plus, and hydroxide is OH-, making KOH, reacting with sulfuric acid, and it says acid, so that means we must have H plus on the front, and since it ends in ic, that's sulfuric, ends in ic, the original ending was 8. We're looking up sulfate on our negative list, which is SO4 2-, and that gives us then, when it comes together, H2SO4. We have a pair, K and OH, and another pair, H plus and SO4 2-. A pair and a pair means double displacement. The K plus is going to go with the SO4 2-, making K2SO4. The H plus will go with the OH-, making HOH. No, that's not right. It's going to make H2O. Then we balance, and example 6 is complete. Example 7, we have just HBr there, so it must be decomposition. Now, a lot of students will look at this and say hydrogen is a diatomic, bromine is a diatomic, so this will break up into H2 and Br2. But that's not correct because HBr is an acid, and acids are ionic compounds, and we said when we do decomposition of an ionic compound, we break it up into its charges. In an acid, we have H plus on the front, and in this case, we have Br- on the back end. Already balanced. Next question. Example 8, we have zinc reacting with Al2S3. Now, Al2S3, that has Al3 plus on the front, and I recognize that S commonly takes a negative charge, which is 2-. So that means I have zinc by itself, and I have this pairing of aluminum and sulfide. So that means this must be single displacement. So who will zinc replace, aluminum or sulfide? Well, if I look on the periodic table, I see that zinc is a metal. And when it takes a charge, it takes a +2 charge. So that means the zinc is going to want to get together with sulfide. And when Zn2 plus and S2 minus come together, they will make ZnS. Now, that means the aluminum has been displaced. And the aluminum is not going to have a charge because the zinc which was the single coming in, did not have a charge. So therefore, the aluminum, which is the single leaving, cannot have a charge. Now we balance the equation and we move on. Example 9, CoCl3. That is the only thing there, so it is a decomposition reaction. It is ionic, so it's going to break up into its charges. But what are its charges? I have cobalt on the front, which can be a +2 or a +3. So I will have to rely on the anion to determine what the charge of the cation is in this case. The anion is Cl-. There's 3 of them, so that gives me a -3 charge. So the cobalt must be carrying a +3 charge. So I will break up CoCl3 into CO3+ and Cl-. I'll balance my elements and check this out. My charge is also balanced because I have no charge on the left. And on the right hand side, I have a +3 that is canceled out with the 3 -1 charges. So 0 overall charge on either side of the arrow. Example 10, I have CoCl2 reacting with bromine. CoCl2 is a pair, bromine's by itself, so this is single displacement. Again, cobalt can take a 2 or a 3, so we look at the chloride to determine what the charge on cobalt is. Chloride has a -1, so since I have a -2 charge on the back of cobalt chloride, that cobalt is taking a +2 charge. It is reacting with bromine, but who will bromine react with? Bromine is a nonmetal, so it takes a negative charge. When I look it up on the common negative ion list, I see it listed as BR-. Since it is negative, Br is going to want to react with CO2+, forming CoBr2. And that means that chloride is no longer hooked up with cobalt and it will leave by itself. Chlorine is a diatomic, so it can't leave as just Cl, it's going to have to leave as Cl2. The equation is already balanced, so we are good to move on to the assignment. You are working on BR10 and 11. The next class period is a work period to finish the assignment, and the quiz will be in the period that follows that work period.